Happy Tuesday, boys and girls. So today we're going to start looking at some shapes. We're going to move away from the lines and angles a little bit. We are going to use those to help identify our different shapes, our different quadrilaterals, and then eventually into our triangles as well. But for today, we're going to focus on just identifying the different types of quadrilaterals, work on identifying those, and then just knowing the specifics behind each one. So a quadrilateral is going to be any shape that has exactly 4 sides. The first shape that we probably think of when it comes to quadrilaterals is a square. Now a square is a little bit different, boys and girls, because a square can turn into a few different things. However, as it turns into different shapes, different quadrilaterals, it cannot go back to a square. So once it moves away from a square, that's all that we can do. So a square, the first thing that we're going to talk about with our square, it has 4 right angles. Okay, it's going to have 4 right angles. It is also going to have 4 equal sides. With it having 4 equal sides, it's going to have 2 sets of parallel sides, and we'll talk about that in just 1 second. Okay, so with our square, we're going to represent it. We are going to model it out, and with us doing so, we're just going to draw a square down here. We're going to represent the 4 right angles by putting those boxes in the corners, and then to represent that it has 4 equal sides, we're going to draw 1 little tally mark on each side. So these tally marks, these dashes, whatever you like to call them, are going to come back a lot with our quadrilaterals and then again with our triangles as well. They're going to represent that they're either all the same if they all have 1, or sometimes we're going to add in that some sides have 1, some sides have 2, and that's going to represent that other sides are either shorter or longer than the other. Okay, so this is going to be our square explanation. Now a square can then turn into 2 different things. The first thing that a square can then transition into is what we are going to call a rectangle. And I know that we know a lot about rectangles. Rectangles are a very nice transition from a square because they follow a lot of the same rules. They're still going to have those 4 right angles. However, they are no longer going to have 4 equal sides. They are still going to have those 2 sets of parallel sides. That is very important to remember. However, with a rectangle, some sides are longer than others. So like we talked about with the square, we are going to model this out, still representing those 4 right angles, and then to represent that now they don't have all the same sides, but they now have some different side measurements, we're going to draw, again, those dashes, tally marks, whatever you choose to call them, on the smaller sides, and then on the longer sides to represent that these are the same length, we're now going to draw 2 tally marks. So these 2 sides are the same length, and then the top and bottom are the same length. Okay, so that definition of that 4 equal sides with that square goes away, but then everything else stays the same with our rectangle. The other shape that a square can transition into is going to be a rhombus. So we're going to put rhombus right over here. And the way that a square can transition into a rhombus is that it is going to have the 4 equal sides. It's going to have those 4 equal sides that the square has. It is still going to be consistent with the 2 sets of parallel sides as well, but then instead of having the right angles, it is now going to have acute and obtuse angles. So a rhombus, and a nice way to remember a rhombus too is think of it kind of like a tilted square. So we're gonna draw our first line on top, our second line a little bit over, and then we're gonna tilt it over to represent that it has those acute and obtuse angles instead of those right angles anymore. But then again, going back to those tally marks, we are gonna draw one on each side to represent that all the sides are still the same length. So again, it does still have those two sets of parallel sides as well. The top and the bottom will be parallel, and then these two sides will be parallel. They're gonna keep going, never cross, but it's gonna keep those 4 equal sides, okay? So the last little shape that we're gonna talk about with our square transitions is going to be what a rectangle and a rhombus kind of come together and form. The last quadrilateral that we're gonna talk about on this side, our square side of things, is going to be a parallelogram. So with a parallelogram, it's gonna take a few of the requirements, a few of those characteristics of a rectangle. It's also gonna take a few characteristics of a rhombus, okay? So with our parallelogram, it's gonna take the acute and obtuse angles from our rhombus. And then from our rectangle, it's going to bring over the attribute of having the two sets of parallel sides. And one thing you can see within the name of a parallelogram, it already has the word parallel in it. So that's just gonna help you remember that it does have those parallel sides. So with our parallelogram, it's gonna look like a rectangle and a rhombus come together. It's gonna, like we talked about with a square turning to a rhombus, how it's kind of a tilted square. A parallelogram is now gonna be kind of like a tilted rectangle. So we're gonna have that longer line on top, longer line on the bottom. We're gonna tilt those two sides to again represent it having the acute and obtuse angles. With our tally marks, we're gonna represent that these two sides are the same length. And then our top and bottom sides are the same length. Okay, so that is going to be the last quadrilateral that we talk about with our squares. So again, a square can be a rhombus, but a rhombus cannot be a square. Same kind of concept with a square can be a rectangle, but a rectangle cannot be a square. And then going to our parallelogram, a rhombus can be a parallelogram, but a parallelogram cannot be a rhombus. Rectangle can be a parallelogram, but a parallelogram cannot be a rectangle. So with these quadrilaterals, they can work through, but they cannot work backwards. Okay, boys and girls, so the last quadrilateral that we're going to talk about right now is called a trapezoid. Now with a trapezoid, it's going to have one main characteristic, and then we're going to talk about the two different types of trapezoids that you can have. So with our square, our rhombus, our rectangle, our parallelogram, every single one of them has two sets of parallel sides. A trapezoid is only going to have one set of parallel sides. With our trapezoid only having one set of parallel sides, there is a regular trapezoid that we're going to talk about, but then there's also a trapezoid called a right trapezoid. So our regular trapezoid that you're going to see a lot of is going to look like this. It's going to have a smaller top, a bigger bottom, and then the two sides are going to be slanted. The parallel sides that it's talking about are going to be your top and your bottom side. Now again, what we've talked about, boys and girls, with your shapes, even if this trapezoid was turned on its side, it would still have that set of parallel sides. Okay, and then with that right trapezoid that we talked about, it's still going to have the top and the bottom sides being parallel. So I'm drawing those arrows instead of just the tally marks to represent that they're not the same size, as we can see. but they're gonna be parallel. They're gonna go the same direction. Again, never cross, kind of look like railroad tracks. This is going to be a right trapezoid because it has right angles. So this one we can label as a right trapezoid instead of just a trapezoid because it has that one little change, that one little characteristic of those right angles. When we get into our quadrilaterals a lot more, and then also when we get into our triangles, you're gonna see this explanation come back again. Okay, so we're gonna add our last little quadrilateral bubble. And with this one, boys and girls, be very careful because I'm only drawing a connecting line from quadrilateral to trapezoid. Do not connect a trapezoid with any of the other shapes that we've talked about. They do not go together. This one is completely separate from the rest. Again, because a square, rhombus, rectangle, and parallelogram all have those two sets of parallel sides. That trapezoid only has one set of parallel sides. So be very careful with that. Alrighty, boys and girls, these are the only quadrilaterals that we're going to talk about right now. You do have an assignment for today. It is going to be front and back. It does ask you to classify triangles, come up with the best name for them. Also has a little bit of matching, and then again on the bottom, try to identify each one as best as you can. On the back, it's then going to ask you for a always true, sometimes true, or never true statements based upon what we've just talked about in the video. So if you need to go back, listen to a little bit more clarification. Again, like we talked about with rhombus as a square, think about which way it can go, and then come up with your always, sometimes, or never true on the side. You do have 15 of these, boys and girls, so make sure we answer these to the best of our ability, and make sure we fill out those Google Forms.